This is the question from GATE 2019 Physics question paper. Today we will talk about classical mechanics, and the question is from question number 54. The question is, two events, one on the earth and the other one on the sun, occur simultaneously in the earth's frame. The time difference between the two events as seen by an observer in a spaceship moving with velocity 0.5 c in the earth's frame along the line joining the earth to the sun is delta t, where c is the speed of light. Given that light travels from the sun to the earth in 8.3 minutes in the earth's frame, the value of mod of delta t in minutes rounded off to 2 decimal places is how much? And there is some hints given here that take the earth's frame to be inertial and neglect the relative motion between the earth and the sun. So this is a relativistic classical mechanics question. So we have to answer with respect to the modified expression of time as well as space with respect to in presence of relativity, that means relativistic velocity. So here you can see that it is showing two events were there, one on earth and the other one on the sun. So if I just write here that let's say this is earth and this is somewhere sun and this is spaceship. This is sun and this is our earth. So here in that question they were asking that two events, one on the earth and the another one on the sun, these two events occur simultaneously in the earth's frame. That means with respect to earth's frame, let's say this is the first event and this is the second event. In earth's frame of reference, first event and second event occur at the same time because it is doing that simultaneously. Simultaneously means it will occur at the same time. So if I write here, in earth frame, first incident can be denoted by, let's say, x1 prime, t1 prime, and the second incident is, let's say, h2 prime, t2 prime. So in earth's frame we can confirm that t1 prime is equal to t2 prime. That means delta t prime equals to 0. This is nothing but t2 prime minus t1 prime. So here in that question they were mentioning that in earth's frame, one event which occurred on earth and another event which occurred on sun, these two occur simultaneously. The time difference between the two events as seen by the observer in the spaceship moving with velocity 0.5 c in the earth's frame along the line joining the earth to the sun is delta t. That means in that question they are asking about delta t. What is the delta t? Let's say in spaceship frame of reference, I am indicating these two events. First event as x1 t1 and second event as x2 t2. So in that question they are asking about what will be the value of delta t, which is nothing but t2 minus t1. And there is also one more information given, and yes, with which velocity 0.5 into c. That means the v will be 0.5 into c. Another information they have given here that the light travels from the sun to earth in 8.3 minutes in the earth's frame. So light is coming from sun to earth in 8.3 minutes. Light coming from sun to earth is, let's say it is t and this is 8.3 minutes. Okay, so now we have to calculate the value of delta t, which is t2 minus t1. So first of all, what we will write, we will just calculate T2 and T1 expression. So T2 expression is T2 prime plus Vx2 prime by c square into root over 1 minus v square by c square. And now T1 prime is T1 is T1 prime plus Vx1 prime by c square, and it will be like T1 prime plus Vx1 prime by c square by 1 minus v square by c square. Now we can see that in the from the previous condition, T2 prime is equals to T1 prime and V is 0.5 into C. So we need to calculate delta 2, which is T2 minus T1. Now we can see that 1 minus root over 1 minus v square by c square, that will be common out, and it will be like T2 prime minus T1 prime plus v by c square into x2 prime minus x1 prime. Now from that expression, it is already given that T2 prime is equals to T1 prime, that means delta T prime is equals to 0, which is given as, this will be 0. Now v by c square, v is given as 0.5 into c, this whole square divided by c square. Now x2 minus x1, x2 prime minus x1 prime. Then what will be the value of x2 prime minus x1 prime? That will come from that expression that time from the light is coming from earth to sun to earth is 8.3 minutes. So what is the advantage of this expression? The advantage of this expression will be like, here we can write x2 prime minus x1 prime, which is delta x prime, is 8.3 into c into 60, because 8.3 minutes are there, so minute into 60, that means we are converting it in a second and we are multiplying that in with c, because light is coming with the velocity of exactly c. So this is nothing but the delta x prime. Now again we are just putting the values here. Now 1 minus 0.5 whole square into 0.5 whole square into 8.3 into 60. You can see that here the c square is there, and then this will be like 1 minus v by c square, it will be v by c square, so that means it will be 0.5 into c, and 0.5, and this c and this c will cancel out, that means it will be c into c divided by c square. So the c will cancel out from this and it will come as 1 minus 0.25 into 0.5 into 8.3 into 60. So that will be the exact value in second unit of delta t. Now if I just calculate, it will be delta t equals to root of 1 by root over 1 minus 0.25 into 0.5 into 8.3 into 60. Now if I just calculate this one with the help of calculator, then it will come as 4.79 minutes, and the answer will be the value of delta t in minutes as 4.79.